All right, here we go. Let's graph y equals parentheses 4x squared plus 1 divided by negative 2x squared minus 3. Zoom 6 to reset the window. And, well, that's interesting. It looks like a mustache. Or it looks like the highway in Florida, the elevation of the highway in Florida, and that's an on-off ramp to the expressway. If you've been to Florida, it's very flat. Okay, so let's see. I'm going to press the trace button, and 0, it looks like the y-intercept is at a -3rd, so right there. And then, like yesterday, let's do the following. Let's do second graph. Oh. All right, I'm going to do, did I show you the table set? I'm going to do second window table set, and I'm going to start my table at 0. Then I'm going to go to the table, and I'm going to scroll down. And as x gets bigger, what number does y get closer to? Looks like it gets closer to 2. Okay, table set, 0. Table, now as x gets smaller, what does y get closer to? Yeah, -2. So it looks like we have some sort of asymptote at -2. And there's our mustache. Okay. So this is what we discovered as x approaches infinity, the limit of y equals -2. Or as x side arrow infinity, comma, y side arrow -2 with a superscript. This means as x approaches infinity, y approaches -2. Is it coming from the top or the bottom? It's coming from the top, so it would be plus, like that. Or we could say the limit as x goes to infinity of the function y is or equals -2. Those are all ways to describe that horizontal asymptote. And we've already done this. We went up in the table and we discovered as x approaches -infinity, the limit of y equals -2. Or as x side arrow infinity, comma, y side arrow -2, superscript positive, because it's coming down from the top. So as x approaches infinity, y approaches -2 from the top. Oh, yeah, right, -infinity. Oh my goodness. Thank you for catching that. Or the limit as x goes towards -infinity of the function y equals -2. Oops, okay. Now, do you remember using the trace button yesterday? Here, let's just do it again. If you do the graph, and you press trace, I've got 0 and the y-intercept is negative 0.3. As we trace sideways, you can see the y values in the lower right-hand corner get closer to negative 2. And you can trace to the left and you can discover the same thing. And so the trace, using the trace function and using the table, accomplish the same thing in two different ways. So what is happening to the y values as we trace? They're going towards negative 2. And does this match what we found above? Yes, it does. The trace function and the table function give us the same information. All right, what's the equation for that horizontal asymptote? Well, it crosses the y-axis at negative 2, so that's the equation. Why is it that this equation tells us that? Well, here's what happens. As x goes towards infinity, the plus 1 and minus 3 terms become insignificant. So those terms right there become insignificant. So as x goes to infinity, y is approximately equal to 4x squared over negative 2x squared, because those terms just make hardly any difference. And if you simplify this fraction, the x squareds cancel, and 4 divided by negative 2 is negative 2, and that's our asymptote. Now, in this region right here where the x values are small, how come the function doesn't look like the asymptote? Well, 4x squared plus 1 over negative 2x squared minus 3. Those numbers right there are significant, they are meaningful when x is small. You know, it's like saying $1 means a lot to a poor person like me, but it means nothing to a billionaire. Significant when x is small, insignificant when x is big. Hey, let's turn the page, and based on what we know, let's look at some of these. So it says, graph this rational function on your calculator. Does there appear to be a horizontal asymptote? If so, give the equation. Shall we graph first, or shall we make a prediction? What do you think? Well, let's graph first. Okay, so y equals 2x to the third plus 4x squared minus 6x divided by x to the third plus x squared minus 16x plus 20, zoom 6, what do you think? Does it look like there's an asymptote there? Now remember, the asymptotes only really affect the function when x is big. So if you look way out here where x is big and way out there where x is big, does it look like there's an asymptote? Yeah, it does. I'll tell you what, let's do something. Let's do something. As x gets really big, y equals now let's look at this function. If x is really big, how does x cubed compare to x squared? Yeah, x cubed is going to get a lot bigger. The bigger x gets, x cubed is going to be way bigger than x squared and bigger than x. So those terms are going to become insignificant, and we could consider them 0. How about x cubed compared to x squared, x and just a number 20? Same thing. Those become insignificant, and when x is big, the function y acts like 2x cubed over x cubed. And that simplifies to 2. So, I'm going to go to my calculator. I'm going to put a second equation in my y equals. I'm going to put y equals 2. Does it look like there's an asymptote when x gets big? Yeah. In fact, we could go to our window and we could make this, we could go negative 20 to positive 20 in the x direction. So there's the function, and yep, there's the asymptote. When x is big, the function acts like y equals 2. Let's do another one. Okay, graph y equals x plus 2 over 2x squared minus 2. So parentheses, x plus 2 divided by parentheses 2x squared minus 2. I'm going to reset my window, zoom 6. Does it look like there's an asymptote there? A horizontal asymptote? Well, what's it doing way out here? Is it following a straight line? Yeah. Where does that straight line cross the y-axis? Let's see. There's plus 1. There's minus 1. What's the y value when you're on the x-axis? 0. Yeah, let's do something. Let's go to y equals and plug in 0. And then graph. And look, there's the red line. There's the asymptote going right across there. So, here's what's going on. As x goes towards infinity, let's look at our function. X gets really big, and 2 becomes insignificant. X squared gets really big, negative 2 becomes insignificant, and y starts acting like x divided by 2x squared. Now, let's simplify this. Wouldn't this be the same as 1 over 2x? Well, as x gets really big, as the denominator gets really big, what happens to the value of this fraction? As the denominator gets big, the value of the entire fraction gets small. Yeah. Imagine 1 over a billion. It'd be insignificant, it'd be small. So it ends up being 0. And that's where the asymptote was. The asymptote was right across there at 0. Let's do another one. Y equals parentheses 2x squared plus 5x minus 3 divided by parentheses x cubed plus 3x squared plus 2x. Well, let's see what happens when we graph this. Does it look like there's a horizontal asymptote on that one? Does it look like there's a straight line out here when x gets big and small? Yeah, it looks like it's going towards y equals 0. Let's do that. Y equals 0. Watch the red line go across. When x is big and small, is the function right at y equals 0? Yeah, let's see what's happening. As x gets big towards infinity, x squared is going to be bigger than x and bigger than 3, so those terms are insignificant. X cubed is going to get way bigger than x squared and x, so those become insignificant. And y is approximately equal to 2x squared over x cubed. And if we simplify this fraction, it becomes 2 over x. And what happens to the value of the fraction when x gets really big? The fraction gets really small, and it's about 0. And that was where our asymptote was. All right. There's another one. Holy mackerel, lots of things to graph today. Let's graph parentheses 2x cubed plus x squared minus 1 divided by parentheses x squared close parentheses. Do a zoom 6, reset the window, and oh! Does it look like there's an asymptote? Let's go out further. Let's increase this to negative 20 to positive 20. And let's see what it looks like. Doesn't it look like a diagonal asymptote? Yeah. So, does there appear to be a horizontal asymptote? No. It looks like that. That's crazy. Looks diagonal. All right, we're going to skip that. Let's try this next one. Y equals parentheses negative 3x to the third power plus x squared minus 1 close parentheses divided by open parentheses x squared minus 1. close parentheses. See what happens. Oh, you know what? We need to, I think I need to reset my window. Zoom 6. You know what I'm going to do? Instead of increasing the X, I'm going to change this window and I'm going to increase the Y. So negative 30 to positive 30. Let's see if that helps us see it. Does it look like there's an asymptote there? Yeah, it looks diagonal again. Alright, so it looks like there's some sort of crazy asymptote like that, and it looks like it does that, and then it does that, and then it does that. You know what? I'll bet it doesn't cross here. I'll bet I did this wrong. I'll bet it does that. There we go. Well, let's see. What's the question say? Does there appear to be a horizontal asymptote? No. It looks diagonal. All right, let's flip the page. All right, what's the leading term in the numerator? It's 3. And the leading term in the denominator is 1. So 3... Oh, you know what? There's a mistake here. This is supposed to be 3x plus 1. Got to fix that, please. So, really, the leading term is 3x, and the leading term in the denominator is 1x. And the equation for the asymptote, if you look back, do you remember what it was? Flip back and take a look at it. This is the very first one that we did. You find it? It was 3. Yeah, right on. Hey, I'm just going to do a little thing. Numerator divided by denominator. What's 3x divided by 1x? 3. Okay, for function b, the leading term is 4x squared, and the leading term in the denominator is negative 2x squared. What was the equation for the horizontal asymptote for the second one? That was the mustache one. Negative 2. Hey, what's the leading term of the numerator? 4x squared dividing by leading term of the denominator, negative 2x squared. What does that equal if you simplify it? Negative 2. Interesting. All right, C, the leading term in the numerator is 2x cubed. The leading term in the denominator is x cubed. If you look back, what was the equation for that horizontal asymptote? Was it y equals 2? Yep. So the numerator is 2x cubed, and the denominator is x cubed. If you simplify that, what do you get? 2x cubed over x cubed is 2. Yeah, very interesting. Okay. For letter D, the leading term in the numerator is x. The leading term in the denominator is 2x squared. What was our asymptote for that one? 0. And if you do x over 2x squared, well, there's more x's in the denominator than in the numerator. We'll just leave it like that. Okay, letter E, 2x squared in the numerator and x cubed in the denominator. The equation for the horizontal asymptote was 0. And if you divide numerator and denominator, it's 2x squared over x cubed. Okay. Letter F, leading term numerator, 2x cubed. Leading term denominator is x squared. If you divide those, we have 2x cubed over x squared. And we had no horizontal asymptote. How would you want to describe that asymptote? Diagonal? All right. Diagonal asymptote. And the very last one that we did, the leading term in the numerator was 3x cubed. In the denominator it was x squared. If we divide those, negative 3x cubed over x squared. And that last one also had a diagonal asymptote. Well, I see 3 different horizontal type asymptotes, 3 different cases. I see case A, B, and C. I see case D and E, and then F and G. What sort of patterns do you notice? I'll give you a hint. Look for the patterns here. Anybody see pattern? I'll help you out. Let's look at this one. The first 3. What's the degree of the numerator compared to the degree of the denominator? They're the same. So case number 1, degree numerator equals degree denominator. That's case number 1. Okay? What do you notice about case number 2? Yeah, exactly. The degree in the numerator is smaller than the degree in the denominator. How about the very last 2 cases? Yeah, the degree of the numerator is bigger than the degree of the denominator. All right, let's start at the bottom and work our way up with some conclusions. If the degree in the numerator is greater than the degree in the denominator, do we get a horizontal asymptote? No. In this case, there is no horizontal asymptote. How about if the degree in the numerator is smaller than the degree in the denominator? Is there a horizontal asymptote? Yeah, and it's equal to 0. So we would say the horizontal asymptote is located at y equals 0. And how about if the degree in the numerator and denominator are the same? Then how do you determine the horizontal asymptote? Hey, I'll give you a hint. What if our equation looked like y equals, I don't know, we'll say ax squared plus a bunch of stuff, and the bottom was bx squared plus a bunch of stuff? What would the horizontal asymptote be? Be a over b. Yeah. So it'd be the lead coefficients. Yep. So we could just say lead coefficient divided by lead coefficient. Groovy. All right. Flip the page. Use your findings from the table to write equations for rational functions that satisfy the following. Do not use any of our previous examples. If we wanted a horizontal asymptote at y equals -5, what would our rational function have to look like? Would the degrees in the numerator and denominator have to be the same or different? They'd have to be the same. So we could have anything like x squared over x squared, and then the rest of the terms don't matter. What would the lead coefficients have to be in order for it to end up at -5? Yeah, two numbers that divide into -5. So we could do -5 over 1, -10 over 2, -15 over 3, and so forth. So if we did that, we'd get a horizontal asymptote at y equals -5. How about a horizontal asymptote at y equals 0? What do we have to know about the degree of the numerator and denominator? Look back at your table if you need to. The denominator has to have a greater degree. So if we had x to the 4th and x to the 5th, and then whatever terms we wanted, we would get a horizontal asymptote at y equals 0. How about something that doesn't have a horizontal asymptote? Degree in the numerator would have to be higher, so we could do something like x cubed plus 1 divided by x squared minus 1. And that would give us a non-horizontal asymptote. Okay? Let's see. Today's Wednesday, and we get done at 9:25. So with this time left, I will let you finish the rest of these questions, And we'll check them tomorrow and use these as a jumping off point for figuring out our diagonal asymptotes.